Hi, and welcome to Intel on AI, the podcast that connects listeners with leaders. This is our first episode of 2025. My name is Heather, and I'm going to be your host. Our first guest today is Luke Norris. Luke Norris is the co-founder of Kamawaza AI, driving enterprise AI innovation with a focus on secure, scalable Gen AI deployments. With extensive experience raising over $100 million in venture capital and leading global AI ML deployments for Fortune 500 companies, Luke is passionate about enabling enterprises to unlock the full potential of AI with unmatched flexibility and efficiency. Luke, welcome to Intel on AI.
Thank you. And thanks for that introduction. It's quite a lot.
It's all you. It's very impressive.
I appreciate that.
It's amazing to hear it all together, isn't it?
It is. Humbling.
We have about a 30-minute chat today, and we have a ton to get through. So I'm going to launch right in if you're ready.
Yeah, let's do it.
Great. So I want to talk first about data architecture. Now, you've been working to rethink enterprise AI data architecture. How does the current system work, and how would you like to improve it?
I think the current system is stuck in proof of concepts, proof of value, and it really is where they've had to move data to the AI engine, the actual processing of that data and the AI itself have had to sort of come together. What we're seeing in the Global 2000 Fortune 500s is the agentic approach, an agent that actually executes autonomously on a goal or a task. It needs all the data, and it needs access to data at multiple locations, multiple SaaS services, and that can also span multiple geolocations. So what I'm hoping the world starts to adopt is they bring AI to the data. That's a paradigm change. That allows a ability for an agentic service to access that data wherever it lives, process it anywhere, and actually get a full outcome. And that's where the enterprises are going to find that next step in value from AI.
It becomes a concept of efficiency, which has been a very popular word lately. Of course, all businesses are looking to improve. So talking a little more about efficiency, and I want to move this over to the topic of multi-LLM strategies. What are the risks of not embracing these new models?
I think there's a lot that question that you just posed. First off, the innovation on the open source side when it comes to LLMs and the new model innovations, it's incredibly rapid. Here at Kamawaza, we actually call it as Christmas every week because it literally seems like there's a new breakthrough, a new paradigm change in the open source models that comes out literally every week. Secondarily, the innovation cycle is all over the globe. So the ability to follow the new technology and the new services wherever it comes from is another major sort of step forward. Third, I think it's incumbent for the enterprise to understand something that might be very complicated today is going to be easily processed tomorrow because of this innovation, because of the new refresh cycle. And last in what you said, I think the ability to mix models is where the sort of future resides. The ability to run a large world model against and with a bunch of small SLMs is where you're going to start to get, once again, agentic services that can sort of mix and match across the entire enterprise.
And so it becomes an issue of scale as we move forwards with these processes using smaller businesses, larger businesses, and how they all come together.
Yeah, absolutely. But I also think replace business with business unit. You're going to have small business units within larger companies that are going to need their point solution, but it should all tie back to the larger governance, the larger processes, larger oversight of the enterprise. And that's where the world models can oversee the smaller models.
I think right now I'm feeling like one of my really direct interactions with AI at this point is with agents in customer service situations. You're typing on the computer. I know that someone is sort of trying to market and funnel my way to help me out. So when we talk about the rise of autonomous AI agents in enterprise, what are some more of the behind the scenes uses for these agents, and how can they benefit businesses?
Yeah, and I think this is where we were just talking about all these new models and features and functions are coming out. the chat interface is like the worst way to interface with AI. And what I mean by that is AI is just so powerful. Yeah, so powerful. So what we're seeing is the ability to establish a 24/7, 7 days a week, back-end process that is always running. It is always looking for the new data to be uploaded. It's always looking for the files to be changed. And it's always waiting for some pipeline to kick it off and start its process. And when you do that, you can start having amazing outcomes. And these outcomes are really augmentation of current knowledge worker processes. Everything from, you could turn on my favorite one here is the procurement agent. It's just my absolute favorite. In large enterprises, in medium companies, they have hundreds and thousands of contracts with software vendors and services vendors. Those contracts have ad orders, they have entitlements, they have very nuanced details. When you're in a large company, each line of business might have their own contracts, they might have their own entitlements, they might have their own ad orders with all of it. You can put all of that together in an AI framework. You can have an AI procurement agent that now can rationalize all contracts, all services, all entitlements. It can then upload that to software services that tell you what software is actually being utilized. It can then lay out a 2 or 3 month purchasing plan that tells you renew with this exact license structure at this exact price, have all the EU laws, the enterprise license agreements, change their language to match this, to give you a rationalization, a cost, service, everything. And that's just like the tip of the iceberg of starting a procurement agent. And it goes on and on from there.
One really, really cool part of my job is that I get to, I wouldn't say stalk, let's say research. Research is a nicer word. The people that I get to interview, and I got to spend quite a bit of time on your LinkedIn profile. I did scope your Instagram a little bit as well. That's got some more personal things on it. But listeners, if you are not following Luke Norris's LinkedIn profile, you should. It is filled with an enormous amount of insightful articles and videos that are all about kind of the depth of your passion for this industry and how you're really, really looking to think and grow differently. One of the articles that I found the most interesting was your discussion around the 5th industrial revolution. Now, do you think there was a defining moment or breakthrough that marked this shift?
For me, it's when models went multimodal. So when you could not just process language, but you could process video, you could process audio, the full spectrum sort of came into play. And most recently, computer use. So the ability to have these models access the tools and functions of a computer, just like a human, really opened up, I'd say, the full breadth of moving to full agentic workloads. Getting these enterprises easily now could adopt 25 to 30% process automation across the entire organization, and they could take that step into the 5th industrial revolution in my mind.
And what do you think AI's duty? It's a big word. It's duty. It's job. What do you think AI's duty is in transforming human productivity, but more importantly, enterprise value?
Duty is a big word. I don't know if I could step all the way into that. I'll say this. When we're working with the enterprise, we're talking about, it's what Kamiwaza means, superhuman capability, not just replacing a workflow, but what is that dream workflow? What is that dream output? If you had unlimited resources, unlimited knowledge to throw at something, what would be that next level that you would move it to if you had this capability? And that's where it starts to get really fun. Like I said, back with that procurement agent use case, it wasn't just consolidating everything. It was going out and checking all the actual use. It was them reporting that use and actually putting that into the algorithm of what you were going to put into Renew. That next step, that 20% difference, makes 100% value difference to the organization. And those are typically use cases that don't get funded. Those are things that are so beyond the effort that it would take from a manpower aspect in today's work, that now the agents and that AI can take to that whole new level. And that's what we're really excited about delivering.
And when we talk about the impact of human productivity, every revolution is usually an advancement in technology. And those are always built by pioneers. And I kind of consider you're sort of one of those pioneers that is really looking to continue to advance this technology. But pioneers always get asked the same question. And now I get to ask that question to you. How do you tackle the thoughts around AI replacing existing jobs?
You're right. I get asked every time. and I don't think I have the best answer, but I have an answer. So I see this as really a K approach to the market. And what I mean by that is you're going to have the 50, 60% of data input, data processing that is going to be replaced with AI. But then you're going to have that 50, 60%, the top part of the K, that is the knowledge worker, and they're going to get enhanced by that 20, 40, or 50%. And I do think those things are going to have a very large impact in the long run, in a positive, because now you're going to be able to have so much more productivity, so much more insight, so much more value derived in the enterprise. That's such a much better margin profile. I think it just opens up so much more resources to be put back into R&D for new products, new features, new functionality to come to market. But there is going to be that short-term, very painful bottom part of that K that I talked about of simple data processing, data entry, and data sort of manipulation that AI is going to do at a superhuman level today out of the gate, and it's going to make a big impact on that. So in the short term, I think it's going to be rough. In the long term, and long term in AI is not that long. We're talking 5-7 years. I think the output, the benefits are just so going to be exceeding. It's well worth it.
And when we look at some of those concepts of AI growth, we've been talking a lot about sort of individual enterprise or individual businesses. When we scale that out into global governments, how can nations start to embrace this type of efficiency and growth?
Oh, wow, that's a big one. You know, I don't know if I have the macro answer, but I do have a tactical answer, which I think is fun. We've actually done a project with Department of Homeland CISA. It's the Cyber Infrastructure and Security Group of DHS. And we did this amazing sort of work in proving out the effort and then eventually presenting it. And soon there'll be an online tool that anyone will be able to access around it. It's amazing. It took 90 years of data around atmospheric pressure, low barometric pressure from hundreds and hundreds of sensors in America and some sensors worldwide at Air Force bases. And just think about that, 90 years of weather sensors. So the actual data set was in many archaic file formats that don't exist now. Like literally just don't exist.
Like a floppy disk.
Practically. Sort of stuff was written by hand and like put in a BAM or BMC file. I don't even know this stuff. It's crazy. And it's spread everywhere. Multiple colleges have it. Multiple data sets just reside in multiple locations in these different file formats. And just think of the breadth of the files. So it's a heartbeat that's just sort of collecting this data for 90 years from all these sensors. To have the human effort put into it to actually collect all that data, get it in a standard file format, clean all that data, process all that data was staggering. It was so big, humans couldn't take on the effort. You'd have to have a team of hundreds, if not thousands of people working in concert, coordinated to even get it. We were able, with Intel's help, actually turning on a very large cluster of Gaudi 2s and Gaudi 3s. We're able to turn on multiple agent-based services. Our partner, known as Government Acquisition Corp, was helping us with their data scientists, telling the agents what to do. The agent went out over the internet, grabbed all the data in all the different formats, unpacked it, wrote the applications. It literally was writing its apps in real time to open those files in the formats, unpack them, put them all in a standard file format, go through, clean up all the sensors. We're talking multiple trillion points of data, 1.3 billion rows in the parquet, and putting that all together and then writing the apps to actually build all of the graphs and then come back and tell the data scientist what anomalies it was seeing so it could then get permission to remove those, and then what insights it was seeing, and then put those in the graph form. We're talking 30, 40, 50 man years of work that was accomplished in a weekend. And now the government has an incredible tool that can actually say the next time a barometric pressure event like this is going to hit this exact zip code, here's all the costs of insurance last time it did it, here's the cost of life or what other problems there were. It can now have a direct correlation to the future low barometric pressure event, saying if another one hits this exact zip code, here's what we can expect. That is a massive deal. And we're talking something as simple as just saying, hey, we need to increase gutters from 2 inches to 4 inches will save us $2 billion. next time there's a barometric pressure event like this. It's just the forward forecasting, the beauty of bringing AI and technology to the government. And that's one little use case. I can't imagine that at a scale.
Yeah, you can imagine that if, a government were, or, as we start to expand our space exploration, which I think the world is interested in continuing to do, that if you can study those patterns and you can study every single thing in movement and you can be studying data from around the world in real time, how much more effective our tests can be. Maybe we don't need to have as many. Maybe there's sort of a more direct way to have less mistakes, therefore saving billions and billions of dollars in space exploration.
Totally. And you also, that space exploration, but I'm just thinking the random proactive ability for the governments now to adjust to change, the proactive ability for governments to react in real time, like you said, and the ability to say, hey, once again, the gutter use case, if we just make this small change, it's going to save this much money over time. And just having those cheaper investments versus the cost is obviously always more expensive to react after the fact.
Which also becomes directly affected to the individual, which is nice. When you can sort of hear, rather than go do this, but we can't tell you why, or we're going to jump over and now do this. It's sort of saying we have an enormous amount of data that will tell us that going from 2 inches to 4 inches on your gutter is going to save you from replacing your roof. And you go, great. Thank you.
Yeah, it's amazing.
Absolutely. Okay, I'm going to move on. I want to move over to the Inference and Leverage Index. So how does hardware agnostic AI inference affect enterprise scale intelligence?
So there's a lot to think about. Right now, the zeitgeist out there is thinking about AI's training, the massive computers and data centers that are required to train these models from the very large, massive data sets that are out there. The difference is that that's almost scared the enterprise to adopting AI and operationalizing it, and that's called the inferencing. And the amazing part about inferencing is you can start incredibly small and scale it up. Where we're training, you have to start incredibly big and actually scale it down. So it's a different mindset. And what's now happening is there are multiple vendors, obviously Intel taking the lead on this, that are now bringing the capability to start with 2 servers, 3 servers, 4 servers with decent power envelopes and actually start building agentic services in the enterprise. I love this, just sort of one little thought. 3 Gaudi servers running a median-sized model can generate, let's just say, 30,000 tokens a second. A user, a human, can only digest or read at its fastest or type at its fastest about 20 tokens a second. So you're talking those 3 servers could represent 1,500 plus PhDs now incorporated into an enterprise. Like, what could you do with that much processing power, with that much new information, with that much new workloads, in just, frankly, 1,500 new PhDs now on your staff 24 hours a day, 7 days a week. So it's amazing to think about. And the silicon sort of neutrality approach is just saying everyone's focused on training. Everyone's typically then focused on possibly NVIDIA. They've really done a great job winning early the training segment. And there's a lot of incumbents coming at it. But the ability to right size the GPU and CPU at the right location to do the right level of inferencing off the right level of data, once again, bringing AI to the data, is where the enterprise is now going to start to unlock that data, get those workloads moving, get those PhDs processing for them, and really start to make the workflow changes that they're looking for.
And as we move into the topic of monetization, the SaaS model has been industry standard. Does it still fit for these AI native businesses?
I think that's a hard no, like a very hard no. The SaaS model typically is measuring some sort of usage. And in that SaaS model, right now, the sort of thematic use is 1 million tokens. How much does it cost for you to process either known input tokens or known output tokens? But when you're establishing a agent to run 24/7, 7 days a week in that background process, always scanning, always being vigilant, always being ready, it's always processing those tokens. And you don't want to be paying for something when it's quote unquote idle, but it's not actually idle. It's waiting for that next process kickoff. It's waiting for the next file to go. It's waiting for the handoff from another agent to come into play. That's where I do believe the business model, the model needs to move on-prem. It needs to move to dedicated resources, whether those are dedicated resources in the cloud, dedicated resources on-prem, dedicated resources at the edge. Further, the SaaS models typically are their shared GPU services or shared CPU services, and that's typically far away from the data. So if you just follow the themes of this podcast so far, we want to move AI next to the data. We want to have AI always running next to the data and always processing next to the data.
And in regards to inference, how does inference affect pricing for enterprises?
I've been talking a lot in two different modalities, and that might be the wrong word, but I think there's agents that need to be immediately responsive, and there needs to be agents that are processing. And the agent that needs to be immediately responsive has a totally different inferencing cost. Needs to be loaded into the fastest GPUs that can get the fastest time to the first token. Therefore, if you're interacting with it, you're not waiting for that token to come back. You're getting the immediate response you need. Then there's sort of, how do I get inferencing at the right price, at the right process for it to be in that background? And that has a different paradigm, because all you're caring about there is it's getting its job done, the work to be done, the work to be handed off to other agents, and you want to do it at the right price and the right power envelope. And those are two sort of competing things in the inferencing world. And that's where, finding vendors with an incredible large breadth like Intel that can mix Xeon 5s and the 6 CPUs for the background process, and maybe the GPUs like Gaudi 3 for the foreground process is an imperative partner to sort of match up with.
Now, all of this growth obviously comes with power growth. Now, has there been an under-the-radar conversation surrounding how we power this AI technology to scale?
I don't know how under the radar it is, but I do think it's counter-prevailing. So, both on the training and the inferencing side at scale, that like fifth industrial revolution size, where now you have 25, 30% of your enterprise being fully automated, that is going to take a lot. And I mean a lot of big servers and big power. It's well going to be offset by the ROI and the cost efficiency. But to do this, I think in the medium term, we're not talking about the power grid. And this is where I think the conversation outside of Silicon Valley needs to be opened up a little broader. We're actually talking about localized power capabilities. We're talking the ability to have the power generation literally on campus in these data centers. We're talking primary power is going to come from things like natural gas and abundant sources here in America, while we wait for the 4 or 5, 10 years it's going to take to get the power grid in America upgraded enough. So then things like nuclear power and large power generation can augment that. And I think that that's not something that's widely spoken about, but the reality is you look at XAI's recent data center, I think that thing is entirely powered off a local generation from oil and natural gas, and that is going to be the model in the short term.
And do you think there are sort of current power companies that are starting to invest and build in this type of infrastructure, or is it still theoretical at this point?
No, I don't think it's theoretical. Like I said, it's currently being implemented. I think the investments are definitely happening. I don't think it's the power companies per se that are powering that local generation. These are newer companies. I'd call them probably born in the last 5, 10 years that have come up with very efficient, very stable local turbines, gas turbines, and oil turbines to actually power those. And then we have the big power companies working with new technologies like out of the Bill Gates Foundation for small pebble-based reactors on the nuclear side that would go not only next to the data centers, but then also to power the grid for those surrounding areas. And I think we're going to have to sort of implement both, and hopefully the timelines come together.
Amazing. We have 2 questions left. I wanted to mention a recent paper by Signal 65 called The New AI Accelerator Economic Landscape. It is a fascinating 12-page study. Do you think that you could give us a brief explanation of its findings?
I can. So first off, we have a customer called Signal 65. I believe Intel partnered with them to really test out the new Gaudi 3s. And what was interesting is Signal 65 came to us. They wanted a single platform that had real business use cases and real test use cases built into it that was silicon agnostic, would work across sort of the prevailing ones and work with the new providers such as Intel and the Gaudi 2s and Gaudi 3s. So we're very honored that they selected us. More importantly, their findings in working with us were fun, let's put it that way. Everybody looks at AI workloads, as we've said over and over again, more from that training lens. How much pure power, how many flops, how much memory can I throw at a particular problem? And almost, cost be darned, just I want to scale this up in that training scenario. But on inferencing, there's a new paradigm that's taken effect, and it's effectively how many tokens can you process at what total wattage and at what total cost. And then you can build an ROI and you can actually build a use off of it. And then you have not only what it's costing me to purchase it, now run it, but also how much am I getting off of the use of it and the ROIs from that? What use cases does those particular cards? And what their findings showed was there is a growing capability, especially from Intel, especially from the Gaudi 3s, to be extremely price per performant on real world use cases in inferencing. And as the market moves from this training mentality to actually getting ROI and moving to inferencing, and by the way, inferencing should be 300 times plus or minus the size of the training market. Like every enterprise, every small, medium business should be having their own inferencing capabilities and services. This ROI, this paradigm, this growth is going to be imperative. And it's great to see that competitors are starting to get out there. New services and new chips like the Gaudi 3 are making such a dent into that ROI. I recommend everybody read the paper because it helps you change the lens to inference, change the lens to ROI, and actually look at the competitive landscape. And Gaudi 3 definitely stuck out.
It's always so fascinating to hear a topic that there's so much conversation around, and it's so exciting to see someone that's going, but what about from this way, I think? And that's what we have to keep doing. I have one question left. It's a question that I've been kind of like to ask you since you were coming on the show. Are you ready? If this is the 5th industrial revolution, what's going to be the 6th?
Of course you said that. Wow. So the 5th industrial revolution, I think, is, let me just opine on that for 1 second. These revolutions typically take a lot of time. And the first one, like the printing press, I mean, it took a good 100 years almost of humanity to sort of really get in tune. You had to break so many social constraints. I mean, literally like religions didn't even want their books printed by certain people, et cetera. It was like a whole paradigm shift for humanity to absorb it. And each subsequential one has been faster and faster and faster. So I will tell you, I think this 5th industrial revolution is only a 5 to 10 year paradigm. And what do I mean by that? Unlike even, and this wasn't an industrial revolution, but even cloud, if you think of cloud as a general purpose technology, it took a long time for people to adopt it in the economics model. We're already seeing the oldest, largest companies adopting generative AI solutions and overall AI. It is happening at breakneck speed. And then now you layer on robots later this year, beginning of next year, you're going to have information completely moved to sort of Moore's law, and then you're going to have robots moved to sort of a whole nother economic law of labor. And those two things are just going to transform humankind very quickly. So what is sort of the 6th industrial revolution? I think you should probably have Ray Kurzweil on your podcast. He might know a lot more than me and think about it a lot more. But I think it's the new revolution. And what I mean by that is new states of matter, new states of energy, new states of actual work. And then that also means sort of new state of what it means to be human and what it means to actually get sort of enjoyment, not just out of your work, but out of your purpose. And I think that's what we're going to find. And that's what sort of that 6th industrial revolution is going to be.
Amazing. Thank you so much for coming on the show today. This has been an amazing chat. It was so nice to meet you. And I hope you have a really great day. For everyone else, this was just the first episode of the 2025 season of Intel on AI. My name is Heather. Thanks for joining us. Bye, Luke.
Bye. Thanks, everyone.
Visit intel.com/AI to learn more.